guys, good morning. Happy Tuesday. We got another Fan 5 review video for you. Hopefully you were able to come to the live Zoom yesterday, because if you maybe had some struggles with yesterday's Fantastic Five and then looking at some of these numbers, they were fairly low, which we expect on a Monday. But if you did come to the live Zoom, maybe you saw something yesterday that could have helped you with today's questions. So again, you know the drill with this. You should have already done today's Fantastic Five. If you have not, make sure you go back and get that done, then come back and watch. I'm going to start doing it on the actual smart board that you see in class. It's a little bit easier to see and gives me a little bit more room to work. So I'm going to move some of this stuff around, and we're going to get right into it. We're going to start with number 1. It says Philip threw some touchdowns. Peyton threw 5 times as many touchdowns as Philip. Together, they threw 36 touchdowns. It wants to know how many touchdowns did Peyton throw. So I definitely didn't expect anybody to get zeros, because I thought maybe number 1 and number 4 could have possibly saved you from getting those lower scores, because we have had a little bit of experience with them. Now, you still have to read these very carefully, because the one thing I did notice was yesterday, a bunch of people did really, really good math, but they're not reading. That's why that star that I'm going to show you is so important. So let me move this out of the way. Hopefully you don't see that in your way. All right, so I see times as many. It says Peyton threw 5 times as many touchdowns as Philip. So I instantly think, okay, I know I'm doing my multiplicative comparisons. All I got to do now is pull out whatever's being compared in this problem, and I can do my box method. So I know I'm comparing Philip's touchdowns to Peyton's touchdowns. So I'll go ahead and pull those two guys out. We'll put a PH for Philip. We'll put a P, just P for Peyton. And then we got to know where our boxes are going. Well, if it says Peyton threw 5 times as many touchdowns as Philip, that means Peyton's going to get the 5 boxes. 1, 2, 3, 4, 5. And then Philip automatically gets 1. All right, so we're pretty good at this part, just getting the picture. Now you just got to use the information that it gives you. Pull it out. Now we're not going to use the 5. We already used the 5. 5 times as many gave us the picture. The only other number that it gave us is 36. Now you got to know what that 36 represents. In this case, it says together they threw 36 touchdowns. So it doesn't just belong to Philip, it doesn't just belong to Peyton, it belongs to both of them. But now I got to take those 36 touchdowns and I have to split them in between those boxes. And when I say split, you got to think division. And the reason that I'm splitting it between all of those boxes, because again, that 36 is together, represents both of them. So I've got 6 total boxes. And this part right here just comes down to knowing your facts. If you know 6 times something to get you 36, you're good. If you don't, I don't want you to instantly think, ooh, let me get my calculator. List your multiples. 6 times 1 is 6. 6 times 2 is 12. There's different strategies you can use. But if you know your facts, again, 36 divided by 6 would be 6. So there's going to be 6 in each box. And here is where you've got to put your star. Look at what the question is asking. It says, how many touchdowns did Peyton throw? I'm going to put a star next to Peyton. That's who I care about. I'm sure Philip's a great guy. For this question, we don't care about Philip. That means I don't even have to look here. All I got to do is look right here. And I can use repeated addition. I can go 6 plus 6 plus 6 plus 6 plus 6. Or, a little bit easier, I could go 6 times 5. Either way you do it, as long as your math is correct, you would have gotten 30. So, if you're sitting at home and you put A, awesome math, really good math, and that's important, but you've got to read the question. That's why that's star. And really, I should have put the star at the very beginning. I've been inconsistent with my star, but make sure you're looking at what the question is asking and you're given the right piece of information. So, I told you last week we're going to still see that one this week. We're still going to be seeing it in class. Practice will make perfect on that one. So I feel pretty good about that one moving forward. All right, number 2, a little bit different. A review of something that you learned last year, maybe a bit of a bigger number. And I'm going to show you the way that I like to do my rounding. And you're going to get sick of hearing this. It's not my way or the highway. If your way works, keep doing it. And honestly, the way that I'm going to show you, there are faster ways to do it. But I'm just going to show you the way that I like. And if you want to try it, awesome. If not, no big deal. All right, number 2. Charlie ate 3,482 Cheez-Its last year. rounded to the nearest 100, how many Cheez-Its did Charlie eat? So anytime I'm rounding, I like to use something that I call a rounding coaster, and I'll get to that in just a second. But I'm going to start by writing the number that I need to round, 3,492. That's supposed to be a 3. All right, and then it's very important because if I'm rounding, I've got to know what place value I'm rounding to, and in this question it says to the nearest 100. So you've got to know your place value, and that's something we're actually going to see in a couple of weeks in math. Should be a review, but you start with the ones place, tens place, and then the hundreds place. Now, if I'm rounding to the nearest 100, I'm going to underline that number in the hundreds place, and then I'm going to section it off. It's almost like I'm splitting the number in half. I'm going to underline, section it off. So then I'm going to put my coaster around it, just like this. All right, and then your rounding coaster has to have certain numbers on it. So I'll put those over on the side. On the left side, we've got 1 through 4. And on the right side, we've got 5 through 9. Okay, again, not perfect, but you get the idea. All right, next. I did that underline and section off for a reason, because if I look right here, when I said it's kind of like I'm splitting that number in half, I've got to look over to the left side of that line. And if you look right here, you see the number 34. You got to kind of ignore the comma. So if I see a 3 and a 4 right there, I put 34 here, and then whatever number comes after 34, I put on the other side, which is 35. All right, now we still use that line that I just underlined and sectioned off. I'm going to look over to the right of that line. And the number that I see right next to that line is a 9. So I'm going to circle that 9 on my rounding coaster. So now I got to ask myself a question. Let me get some of this stuff out of the way. So I got to ask myself the question, that 9 that I just circled, is it on my 34 side or my 35 side of that coaster? Well, here's my 34 side. Here's my 35 side. That 9 is very clearly on the 35 side. So I'm going to write 35. And then, however many numbers I have over here to the right of the line, which is 2, I add that many zeros. Boom, boom, and that answer would be 3,500, which is B. So again, I'm aware that there are much faster ways to do that. The reason why the rounding coaster is kind of important is some people will find some use out of that, but we're also going to have rounding coaster competitions like speed challenges in class. So the more experience you have with this, at least practicing it or trying it, the better off you might be in some of those competitions, but those will be coming down the road. So that's the rounding coaster. That's what I'll be doing in the videos every day. That's what I'll be doing in class when I'm teaching rounding, but that answer should have been B. And Monday, I'm filming this video on Monday. The numbers on Monday for number 2 were pretty good, so that's great. All right, number 3. I could see why a very common mistake was made on this question. And the one thing that I'll say about this one is we got to be logical. We've got to use our brain when we're choosing an answer to see if it even makes sense. So it says there were 3,293 people at the ECU baseball game. They each brought $4 to spend at the concession stand. How much money was spent in all? A lot of people saw the words in all. They took 3,293, they added 4, and they chose A. Okay? But logically, guys, if you've got 3,000 plus people and that person spent 4, that person spent 4, that person spent 4, it's going to be a lot more than just those $3,000. One word that you got to also consider is each, because we've talked about each. When you see the word each, you could be multiplying. You could also be dividing. Now, a couple reasons why I know I'm not dividing. I'm not putting anything into equal groups here, but also if I look at my answer choices, they're all getting bigger. Now, if I'm going to be using division, my answer choices would be getting smaller. So when I see each, I know that I'm going to be multiplying in this case. We have not done something like this before, so this will be helpful. You got 3,293, and we're going to kind of set it up like we would an addition or subtraction problem. We're going to stack them. We're going to make sure all the place values lined up, and then we're going to do some math. So you start with the 4. You go 4 times 3, which in this case is 12. So I put down my 2, I carry my 1, I'm going to circle it so I don't forget. All right, so I did 4 times 3. Now I'm going to go across to 4 times 9, which in this case, 4 times 9 is 36, plus that 1 gives me 37. So my 7 stays, my 3 goes, circle it so I don't forget. Okay, I'm going to keep moving down the line. Now I'm multiplying it by the hundreds place. I'll go 4 times 2, that would give me 8, plus those 3 would give me 11. 1 stays, 1 goes, circle it so you don't forget it. Last but not least, I'm going to multiply that 4 times the thousands place. 4 times 3 gives me 12, plus 1 gives me 13. Since there's no more numbers to carry over, I'll just put the 13 there, and that would give me C, 13,172. So we've never stacked big 4-digit numbers and multiplied like that, but it's something we're going to end up doing as we get closer, as we move on throughout the year. We're going to end up multiplying those by 2-digit numbers too, which we'll get to that. But this is something that you're going to see in the near future. Now, technically, when you see in all, you could have done addition to solve this question. You could have done, what was the number? Let's see. You could have done 3,293 plus 3,293 plus 3,293 plus 3,293. I think the multiplication's a little bit easier. Again, if you didn't know how to do it yesterday, that live Zoom might have helped you. But if you weren't able to make it and you're just seeing this for the first time, that'll help you to hopefully get that question correct tomorrow. All right, number 4. This is one where very similar to what we've seen last week, but you had to read. Again, there was really good math on this question, but we did not read. It says Zeke did 15 push-ups. That is 3 times as many push-ups as Dak. How many push-ups did they do combined? So what a lot of people did, they did 15 plus 3, they got 18 because they saw combined. Technically, you could use addition, but you wouldn't just add those 2 numbers. I think people looked at combined, but then they just ignored 3 times as many, which we know is so important because we're doing our multiplicative comparisons. So I'm comparing Zeke's push-ups to Dak's push-ups. Let me pull them out. Here's Zeke, here's Dak, and remember, we get our picture from the times as many. It says that is 3 times as many push-ups as Dak. We don't know what that is. You've got to figure out what it's referring to. If you read it just read it in stride. Zeke did 15 push-ups. That is 3 times as many push-ups as Dak. That means Zeke's going to get the 3. Dak's going to get 1. All right. Now we've got to use the information that it gives us. It says Zeke did 15 push-ups. That does not mean there's 15 in each box. That just means his boxes are equal to 15. So now I got to take those 15 push-ups and split them between Zeke's boxes, not Dak's, because those 15 push-ups have nothing to do with Dak. So in this case, I'm dividing by 3. And if I did 15 divided by 3, if I know my facts, that would mean that there's 5 in each box, including Dak's. And here's where people missed it. It says, how many push-ups did they do combined? That's where I got to take these numbers and add. I know that Zeke did 15. I know that Dak did 5. If I did 15 plus 5, that would give me 20. So again, there's really good math on there. We've got to read those questions. That's actually what we're going to be working on either Thursday or Friday, I think. So that one is a little bit new, but it'll get better. All right, last one for real this time. We've actually had one very similar to number 5. It was a couple of weeks ago in Fantastic 5, and we did okay on it. Not good enough to where we weren't going to see it again, so I brought it back for a reason. But it says, Mr. Huber has 36 students. 5/9 of those students wore a tie on Friday. How many students did not wear a tie? So this should look somewhat familiar. And the picture that I'm going to draw should look familiar because I've told you before, anytime that I'm finding the fraction of a whole number, I draw the same picture. Here are my 36 students. All right. And since it says 5/9 of them wore a tie, I'm going to take my 36 students and I'm going to split them into ninths. I mean, I know my pictures are bad, but that one's pretty rough. All right, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so now I'm going to write an equation to match exactly what I just did. I just took my 36 students and split them into ninths. Now again, this gets so much easier if you know your facts. If you know 9 times something, it gets you 36. If you don't, you might have to list your multiples, 9, 18, blah, 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 blah. But if I do 36 divided by 9, that's going to give me 4. Guys, that does not mean 4 is the answer. You've got to know what that 4 represents. That 4 is what I'm going to put in each one of those ninths. That means each of these ninths is 4 students. Let's see if I can squeeze these in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. All right, so it says 5/9 of them wore a tie. 1, 2, 3, 4, 5. Let me circle them. They wore ties. That means these people, no ties. So look at what the question's asking. It says how many students did not wear a tie? This right here is ties. This right here is no ties. So I could go 4 plus 4 plus 4 plus 4, or I could do 4 times 4. Either way, I would get 16 as my answer. So you'll see that same picture every time that I'm finding the fraction of a whole number. All right. So hopefully you saw something in there that helped you. Today's what? This is Tuesday. So tomorrow, Wednesday. Tomorrow's Fan 5, I'd expect you to be at least a 3, especially with 2 of those questions being not Ric Flair. Come on, Mr. Huber. 2 of those questions being multiplicative comparisons that we spent last week working on, and number 5 is one that we've seen in the past. So I think those are 3 questions you could absolutely get correct tomorrow. Obviously, you know where you want to be on a Friday. So thank you guys for watching. Good luck with the rest of your stuff, and we'll see you back here tomorrow.